Hello students, welcome to Target AES. In this video I am going to continue with module number 15 and this module will end the chapter trusses. So we have successfully completed the chapter. If you have some doubts you can obviously ask me, and the most important point which I want to stress is in trusses we have seen two types of trusses, determinate and indeterminate, right? See, we can find forces in both the members, no issues. In indeterminate also you can use sigma x, sigma y, sigma m is equals to 0 and find out forces. But this deflection wala hai na, deflection and rotation you cannot find in indeterminate trusses by the method which we have followed for determinate trusses. Okay, it is very complicated, it will take 2-3 pages and you should not learn it at this point of time. Okay, it is only for ESC mains, not for gate and ESC pre. Okay, so basically we can find forces in indeterminate trusses as similar to that of determinate trusses, but there are one small hack which I want to teach you. Okay, after this the chapter will conclude. So basically if you see a truss, one support will be a pin support and another support will be a roller support, whatever the truss it is. Okay, mostly, but in sometimes in question the questioner wantedly changes this pin joint roller into this roller support into a pin joint support. Okay, why does he do? He does this to induce the redundancy into the truss. Okay, basically when I have a truss something like this, one side roller and one side pin joint, so obviously what will be your external indeterminacy? DSC was R was 3, vertical, horizontal and vertical. So 3 minus 3 equilibrium equation 0. So I was not considered about external indeterminacy because it's anyway 0, and I take the structures which has m minus 2j minus 3 is equals to 0 as determinate structures. Right? As simple as this. But here he is giving us external indeterminacy. Okay, so it is making this truss as a redundant truss. These type of problems are very simple to solve. I will give you 2 examples of such problems and you will be perfect in it. Okay, just let me erase. So what he is doing, instead of giving a roller support, he is making this also pin support. So what is your external indeterminacy? External indeterminacy now is R minus S. Now I have 4 reactions, 4 minus 3 equilibrium equations, so I have 1. Okay, so external indeterminacy has been induced into these problems. These problems are very simple, so don't worry, seeing this actually you will get answer in like 10 seconds. Okay, so let me explain you the difference first and then I will tell you a small note. Okay, so first of all let me make it clear, only small problems will come, big problems will be asked in ESC mains, which we are not focusing right now. So after January, when you clear ESC pre, right, after that we can focus on ESC mains. For now let us concentrate on ESC pre. So if I have a truss something like this and I have a roller support here, okay, I'm not taking a pin support, I'm assuming here I have a roller support first of all. Now can you analyze this? Find out the force in the member AB. Okay, I want FAB. Okay, obviously there will be the force, right? See, when the load is being applied, what will happen? This member jo bhi hai na, this CB member, okay, what it will do? This member will move, right? If I have a truss something like this, okay, if I have a truss something like this and I have applied the load, what will happen? This roller support wala, it will try to move away, right? So obviously this roller support end will try to expand. Okay, when this is trying to expand, this member AB is also expanding, right? This member AB is also expanding, right? So when there is some expansion, obviously the stresses are being induced. When the load is applied and your member is getting expanded or contracted, obviously the stresses are induced. So by default, when you are applying this load W, I can say even without solving, I can say that this is not a zero force member. Okay, my FAB is not a zero force member. Now let us calculate what is the force in the member AB. Okay, how to calculate? First, we can use equilibrium equations at this joint. Okay, to use, what can you do? We can find sigma y is equals to 0 first and find sigma BC, FBC first. Okay, FBC. What you will be getting if I use sigma FBC? See, this angle is 60 degrees, right? So what will be the vertical component? FBC sine 60, right? FBC sine 60. Okay, so my reaction what was my reaction for dot W? It is equidistant, so W by 2, W by 2. Okay, it was going upward, so I am taking it as a compressive force. Okay, FBC sine 60, because my reaction is going upwards. So upwards force should be equal to downward force. Then only it will be in equilibrium, right? So I am taking downward force in the component FBC. Downward force means it is going towards the joint, right? Now it is pointing towards the joint. If pointing towards the joint, it is a compressive force, right? FBC sine 60 is equals to W by 2. So what is sine 60 value? Root 3 by 2 is equals to W by 2. 2 cancel. So what is my FBC? FBC is W by root. Okay, now use sigma x is equals to 0 at the same point. Okay, now use sigma x is equals to 0 at the same joint. So what should you get? Just give me a second. Yeah. Sigma x is equals to 0 at the same joint B. What you will be getting? FBC. Now this component. Now write the horizontal component for this force BC. What you will be getting? FBC cos 60. Okay. So in which direction it will be pointing? FBC, it will be pointing in this direction, right? To make, obviously, to in equilibrium, your right side force should be equal to left side force. So I am assuming my direction as this one in the member FAC. So that is a tensile force, right? Is equals to FAB. That's it, FAB. So what is my FAB value? FBC cos 60. FBC was W by root 3 and cos 60 is 1 by 2. So W by 2 root 3. See, you need not write. I have already mentioned it here. Okay, I have already given the example. If you have hard copy, then more than one. So what is the force in the member in place of pin support? If I have roller support, then what will be the force? The force will be W by 2. Simple, very important concept. Now let us try to understand. In place of roller support, if I have a pin support on, okay, now I have pin support here, right? At the joint B I have a pin support. So I have a truss which is pinned at both the ends. So is it free to move in horizontal direction or not? It is not free to move in horizontal direction. When it was roller, it was free to move, but now it is pin joint, so it is not free to move. So even if you are applying the load W, these joints are not moving apart, right? If this joint is not moving apart, then is it trying to compress or elongate this member? No. So this member AB is not elongating or it is not compressing. So there is no force being induced in the member AB. So obviously, if I have both pin supports, if your movement is restrained, okay, if any of your member has been restrained from motion, then obviously force in that member will be a zero force member. You don't need this. For example, if you have a truss which is pin joint, then you don't need this member, because anyway it will be a zero force member. Okay, these two diagrams are equivalent. Okay, these two diagrams are equivalent. Fine, correct here now. Even in this diagram, even though you have member, it has zero force and it is not helping in the truss at all. Okay, so I hope it is very clear. If some member is restrained from expansion or contraction, obviously stresses in that member will be zero. That is, if stresses is zero, what is stress? Stress is nothing but force by area, right? If stresses is zero, obviously your force in that member is also zero. Your axial force in the member which has been restrained is zero. That is the most important point which you have to remember. Okay, I hope it is clear. Now see the reason. Just give me a second, let me erase this. Now see the reason. Due to the hinge support at A and B, members AB can't expand or contract due to applied loads. Therefore, the deformation is zero. Therefore, force is zero. Okay, if any member has been restrained, okay, from elongating or compression, then the force, axial force in that member will be zero. Okay. Obviously, if the temperature is rise, you are restricting a structure like this. Okay, if your temperature rise, then this body is trying to elongate or compress. Even though the length is not changing, it is trying to compress or elongate. Then obviously you will get forces. Due to the temperature rise, there will be the forces. But in this case, we are discussing about the applied load. If two bodies are restrained and whatever load you are applying, there won't be any axial force in this member. I hope it is very clear, right? due to the applied load, not because of temperature rise. Don't confuse. If the member is restrained and you are increasing the temperature, obviously this member is trying to elongate and it will show some resistance. Therefore, there will be axial forces induced in the member. But when there are some loads being added, applied, not the temperature load, not the temperature stresses. If there are any stresses due to the load application, then obviously the restrained member will show zero force, zero axial force. Okay. So the same example which I have explained above, W2 root 3, when there is a roller support, when there is a pin support, obviously 0. So this is the note, very important note, always remember. In redundant problems, if the load is applied, no force is developed in restrained member AB. If the member AB is subjected to temperature change, then forces will develop in the parity. Okay, if there is a temperature change and the member is restrained, forces are there. If only due to the load application, no forces. Okay. So see, this example is asking us to find what is the force in the member AB. Okay, no need to see, no need to apply equilibrium equations, anything. Just see it. It is restrained at this end, right? You can see it is fixed. At this end also it is fixed. Can it elongate? No. Can it compress? No. So what should be the forces due to the applied load? Here we have applied some load. What should be the forces because of it? Obviously 0. Okay. So now see the member BC. Where is the member BC? So here I have end B, here I have end C. So this is my member BC, right? So obviously it is restrained on this end, it is restrained on this end. Now this BC member cannot elongate, or it cannot elongate, or it cannot compress. So obviously what is the force in that member? 0. Simple. आपको आ जाएंगे 2 mark. Okay, you will be getting 2 marks in ESE and you will be getting 2 marks in GATE. Okay. So see the next question. See, this problem concludes all the different types of problem which you have to learn to analyze the trusses, and this concludes my work. Okay, from now your work start and you have to practice more and more number of questions. Okay, so basically whatever question would be asked from the trusses, it would be from this one. Okay, it would be from whatever I have taught you only. Okay, but there will be some questions which will be little bit twisted. They will be very simple, it will be little bit twisted, and whenever see these questions, don't curse me, but try to attempt. Okay, see this question. If axial rigidity of a member AB is 10 to the power of 6, what is axial rigidity? AE is equals to 10 to the power of 6. Okay, and subjected to temperature rise of 100 degrees centigrade and coefficient of linear expansion is 10 into 10 to the power of minus 6 per degree centigrade. The force developed in the bar. He is asking to find the force in the bar, and he has given some random theory. So seeing this, you will start cursing me कि sir ने तो ये पढ़ाया ही नहीं है. Actually, I taught you this. Okay. So there is nothing much in this question. If there is any such question, please try to attempt. Okay. Before thinking negatively that you haven't studied something, at least try to attempt. You will be getting the answer for sure. Okay. So what has he given? He has given alpha E. So 10 to the power of minus 6. Sorry, 10 to the power of 6. What is the temperature rise? It is 100 degrees centigrade. And coefficient of linear expansion 10 into 10 to the power of minus 6 per degree centigrade. And he is asking us to find force. How to get the answer? Just think for 10 seconds how to get force from this. Okay, you can get stress from this, right? What was your stress? Stress was alpha TE. If there is a member and you are increasing the temperature of this member, what is the stress induced in that member? Alpha TE. Okay, I hope you remember from this SOM concept, right? At least this thing. Elongation due to the temperature rise was L alpha T, and stresses developed was alpha T. Okay. So please be perfect in these small formulas. Never forget it. These formulas are interrelatable with SOM and essay. It should always go side by side, SOM and essay. I will start SOM very soon and you will be perfect even if you don't know. But as an engineering students, I expect you to know at least these formulas, right? The sigma value was alpha T. If you don't know, it is very simple. I will derive in 1 second. So your delta L was L alpha T, right? So what is delta L by L? I am sending L this side, so I will be getting alpha T. Delta L by L is nothing but strain, right? So your strain value is alpha T. Okay, how can I write strain in terms of stress? See, your Young's modulus was stress divided by strain. So what is strain? Stress divided by Young's modulus, right? So stress divided by Young's modulus is equals to alpha T. Therefore, your stress is nothing but alpha T. Okay, what is stress and force relation? Your stress is nothing but force per area. Just cross multiply. Force is equals to your stress into area. What was your stress formula? Alpha Te. Multiply it with area, you will be getting alpha T EA. So what is EA? AE is nothing but axial rigidity. Its value is given, temperature value is given, alpha value is given. You just have to multiply. See this step. you will be getting your answer in 10 seconds. Okay, just think what he is asking and what you can do for 20 seconds. In 10 seconds you are getting answer. Within 1 minute, within 30 seconds you can solve this question. Okay, so what is your answer? 10 into 10 to the power of minus 6 into 100 into 10 to the power of 6, which is 1000 Newton or 1 kilonewton. That's it. Okay, so I hope you are perfect, and no coaching center in India would have taught you this extensively about this chapter. Okay, so be confident. Whatever you have learned, only from there the questions will come, and you have to solve each and every ESE and GATE old question. So some of the questions I have already given. So solve this first and solve each and every question related to ESE and GATE. Okay, so no one will stop you from getting 100 out of 100 from this chapter if you practice old questions. Now let us solve the very first question. This question is very simple. He is asking us to find what is the force in a member A. Okay, I haven't given, but this length was L and each member length was L. Okay, now you can do it easily. Let me tell you the logic here. So you can do it in two ways. Obviously you can find the support reactions, okay, and start analyzing each and every member. Okay, or in simple, I am giving you a small logic, and this logic you can apply to all the symmetrical loading members. Okay, so what is the logic? For example, you can see this is the load acting, right, and it is symmetrically acting on the both sides. Then the forces carried in the symmetrical member, for example, this member and this member will carry same amount of force. This member and this member will carry same amount of force. This member will carry same amount of force. This is because of the symmetrical axis. Okay, so basically if I have some load acting here, say 20 kilonewton, and there is no load, now the symmetry is gone. You can't apply this logic. This is valid only for symmetrical load axis. So you can see this axis is symmetrical about both sides of the trusses. So what you can do, whatever force is there in the member AB will also be the same in this member. Okay, this is also FAB, this is also FAB, whatever it is. Fine. Now let us solve this question. So at this joint, can you tell me what is sigma y is equals to 0? If I use sigma y is equals to 0, what I will be getting? I will be getting a compressive force of 50 kilonewton acting. Agreed? Because your downward force should be equals to upward force. Therefore, at this joint, we should have upward force acting. Upward force yani towards the joint, right? This force should be towards the joint. Therefore, I am getting a compressive force of 50 kilonewton. Obviously, here it is also towards the joint compressive force because it is a compressive member, right? So at this joint B, now you can apply your sigma y is equals to 0. Okay, see, the load is acting downwards, so obviously the force members should be acting upwards, right? It should be acting upwards, away, so that it will be in equilibrium because your downward should balance upward force. So obviously this is upward force carrying members, right? So use sigma y is equals to 0. What you will be getting? So 50 kilonewton should be equals to, your compressive force should be equals to tensile force. 50 kilonewton is equals to 2 FAB. And what is the angle between this? What is this angle? This angle is 45 degree, right? Because this is L and this is also L. So 2F AB sine 45. If this is cos component and this will be your sine component, right? 2F AB sine 45. Sine 45 is 1 by root 2. So 2, this cancel, 25. So FAB is nothing but 25 kilonewton root 2. Okay, 25 kilonewton root 2, that is 25 root 2 kilonewton. Is it tensile or compressive? See the sign which I have taken. I have taken going away. Therefore, it is a tensile force. If a force is going away from a joint, then it will be a tensile force. So how will be the tensile force in this member? It will be like this. Going away, going away. Okay. So this is how your tensile force in the member AB should be represented, and it is equals to 25 root 2 kilonewton tensile force. I hope it is very clear. Okay. Even if you don't know the sign convention, if you assume it has compressive force, okay, if you assume it has a compressive force because you don't know, then what you will be getting? You will be getting minus 25 root 2 as answer. That means you have assumed compression, you got minus, that means it should be a tensile force. Again, like this also you can conclude the answer, up to you. Okay, now see the match the following. This is quite important. It has been asked for ESE for 2 marks. What is it? He has asked us to find what is the force in 4 members. Okay, let us just by see which answer you can answer first. See this joint T, At this joint T, two forces are meeting collinearly and third force is making some angle and it is collinear with this force 60 kilonewton. So obviously the force in the member RT should be equals to 60 kilonewton. Agreed? So whether compression or tension, is it going towards the joint or away from the joint? It is going away from the joint. Therefore it is a tensile force. So where is your RT? RT is 60 kilonewton. Tensile force. Okay. You can find support reactions now and analyze the question. Find the support reactions. Take moment at the point A is equals to 0 and you will be getting what is the support reaction at this point. So taking MA is equals to 0. So what you will be getting? 60 into H plus 30 into 2H, because this distance is 2H, right? Yeah, is equals to RC RQ. Okay, RQ or RC, whatever it is here. RC into what is the distance? 3H, right? So 120H is equals to 3 RCH. HH cancel. RC is equals to 40 kilonewton. If your RC upwards is 40 kilonewton, what is this load? This load should be 50 kilonewton upwards, right? Because total load is 90. Upwards 40 means here it should be upwards 50 kilonewton. Okay. Now you got your answers. 90% of the problem is completed. Let me erase this once. Okay. So as I know the loading, as I know the support reactions, you can apply sigma y is equals to 0, sigma x is equals to 0 at this point, and at this point you will be getting the forces in this member. If I am using sigma y is equals to 0, tell me what should be, first tell me the direction. This is pointing towards the joint, right? So upward force. So I should have some downward force, right? So obviously the sign should be downwards. At this joint the sign should be downwards. That means I have a compressive force in this member. Okay. So how much is the force? You can just use again RS. So this was P, right? So PR sine whatever the angle it was making 45 degrees, right? Because H and this is also H. Sine 45 is equals to 50 kilonewton. So what is your answer? 50 root 2 kilonewton compression, right? I got 50 root 2 is my answer and it is a compressive force. So my PR is nothing but 50 root 2 compression. Okay. Let me erase this diagram properly. Now similarly what you can do? You can cut the structure now. Okay. You can cut the structure. Okay. And you can take moment at this point U. If you take moment at this point U, I am assuming it has a compressive force. I am assuming, okay. I don't know whether it is a compressive or tensile force, right? I am assuming it is a compressive force. So RS I am taking it as a compressive force like this. So I am cutting the member. Now let us take moment at this point U. So what I will be getting? So if I take moment at point U, what are the external forces acting? 1, 2, 3. This point, this force and this force, right? If I cut, these two forces are passing through this point. So therefore you can neglect these two forces. So write the moment equation at this point H. What you will be getting? RS into what is the perpendicular distance? Perpendicular distance is H, right? H. Okay. It is a clockwise moment. So plus 50 into 2H. Clockwise moment. 50 into 2H, right? It is also making clockwise moment. Should be equals to anti-clockwise moment. Anti-clockwise moment is generating from this 60 kilonewton, right? Is equals to 60 into H. Okay, so that is my answer. So what is my answer? FRS force in RH into H plus 100H is equals to 60H. So FRS H is equals to minus 40H. So HH cancel, FRH is equals to minus 40. Minus 40 yani I have assumed it is going away from the joint, right? But actually minus 40 implies it is not going away but it is going towards the joint. Therefore I should have compressive force in the member. If the force is going towards the joint, it is a compressive force. So 40 kilonewton compression. So your RSC is nothing but 40 kilonewton compression. So obviously your SU is 40 kilonewton tension. Okay, if you want to solve, please solve. In exam you don't have time, right? So obviously if you match it 3, obviously you can match the fourth one, right? So please solve. How to solve? Again take method of section. Where is your RS? Where is your SU? SU is this member, right? Yeah. You can use method of section or you can use method of joint. Whatever method you use, you should get 40 kilonewton tension. Okay. That is about this problem. Now this problem very easy. He is asking us to find what is a zero force member. See, let us find out if there is any two members meeting with no external load. No, right? We don't have any such member. Is there any such member? Two members meeting and third member making some point and there is no external load. Again, there is no such member. Three members meeting, right? But they are not collinear. Two members are not collinear. All three are making some angle with each other. So it doesn't count. So what you have to do? You have to go for first method of joints or method of sections, up to you. Now let us find the support reactions. It is equidistant, so W. Now I know W, right? So here what should be the shear force? W Newton. Here what should be the shear force? W minus W, which is 0. So as the shear force is 0 in this panel, what should be the force in the inclined member? 0. Therefore your CF member is 0. Just tick the right answer. Problem is finished. Okay. So find the force in the vertical member UL. So we have to find the force in vertical member UL. Just use sigma y is equals to 0 in this equation. Okay. So I have a downward force of 20. So I should have some upward force acting at this point. Upward force yani it is going towards the joint and it is a compressive force. So what is your answer? Your answer is again 20 kilonewton compressive. That's it. Kitna simple hai bhai? You will be getting your 2 marks in ESE and GATE. Don't worry. Let me erase this and solve the remaining problems. Now let us solve this question. He is asking us to find vertical deflection of a joint C of the frame shown. Okay. So load is acting at the joint C and let this be A and B. Okay. So we have to calculate the vertical deflection. What is the formula? Sigma pKl by A. So find out. First let us find P AC, P BC, and then we will find KAC, KBC, and then summate sigma pKl by AE. You will be getting your answer. So let us find PAC first, PAC and PBC first. See, use equilibrium equation at this joint C. Okay. So what can you use? Sigma x is equals to 0. If I use sigma x is equals to 0, PAC, what is this angle? 30 degrees, right? PAC cos 30 should be equals to PBC cos 30 degrees, right? So obviously opposite sides, because it should be in equilibrium, right? If one is going in this direction, other should come in this direction. So let this be going like this and this will be going like this. Okay, only then they will be in equilibrium, right? So I know PAC will be equals to PBC but with negative sign, right? Agreed? PAC will be equals to PBC but with negative signs. So that's it. Now use sigma y is equals to 0. Okay, so I got something like this. Use sigma y is equals to 0. So what you will be getting? PAC, it is going upwards. So PAC sine 60 plus, if you see this force, it is also going upwards, right? When you are taking vertical component, it is like this. It is making some angle like this. Vertical component will be like this. So plus PBC